Good afternoon, everyone. I'm Sharon Hawks. I'm the director of Nahant Public Library. Thank you for coming here today to a forum with experts on what we called Ick a Tick. And I know that's kind of a funny title. I hope it caught your attention. But behind it is some very serious information about tick-borne diseases, about its spread, about how to diagnose, and about how to prevent getting tick-borne diseases, because we know that the best way to overcome them is to never get them in the first place. This actually is part of a larger project called the Stop Lyme Project, and it was funded by the National Library of Medicine, National Institutes of Health, Department of Health and Human Services, through University of Mass Medical School in Worcester. What all that means is National Library of Medicine, the people that bring you PubMed and Medline Plus, funded a project where we could do a number of things. We purchased ebooks on tick-borne diseases, and they are now available in the statewide ebook platform, Access 360. We assembled a Stop Lyme handbook, and you can see a copy of it when you came in. We offered that. It's now available in 132 libraries at their request. So represents a third of public libraries in Massachusetts. Very exciting there. We also are in process, and by the end of next week, we'll have completed the creation of an online searchable database of helpful and authoritative articles and web pages on tick-borne diseases, affectionately called the Lymebrary. And you can find it. You need a writer. I'm not the only person with a sense of humor about this stuff. You can find it at www.lymebrary.org. And please feel free, if you have any questions, we do have some index cards. Please write them out. We'll collect them after the fourth speaker, and then we can ask them your questions. And then when we wrap up, if you have more things to ask, feel free. I'd like to introduce all of our speakers at once, and then we'll let each of them make a presentation in turn, and then we'll open it up to question and answer. So, at the far end, Dr. Catherine Brown has a Doctor of Veterinary Medicine from the University of Minnesota, a Master's of Science in Wild Animal Health from the Royal Veterinary College in London, and a Master's of Public Health from Boston University. She's been with the Department of Public Health since 2006 and serves as the Deputy State Epidemiologist and the State Public Health Veterinarian. She oversees surveillance for and education outreach on both zoonotic and vector-borne diseases. To her left, Dr. Samuel Donta received his MD from Albert Einstein College of Medicine in New York. He served in the Air Force at Otis Air Force Base, did postdoc training in biochemistry at Brandeis, and did a fellowship in infectious diseases at Boston University. He became professor of medicine and chief of infectious diseases at the University of Iowa, then was at UConn, University of Connecticut, for 11 years of chief of ID, chief of medicine at the VA, and then he moved to Boston University and Boston VA for 10 years. He had an active clinical practice in Falmouth, studying and treating patients with chronic Lyme disease and other multi-symptom disorders such as chronic fatigue syndrome and fibromyalgia, retiring from practice in May of 2015. He's authored numerous articles on toxins, Lyme, and Gulf War veterans' illnesses. He remains active as an infectious diseases consultant at Falmouth Hospital and continues to research and teach about Lyme disease. To his left, Ms. Margot Malachowski is a medical librarian working with the New England Regional Office of the National Library of Medicine. She's located at UMass Medical School in Worcester. Her job is to teach how to search for reliable health information to librarians, teachers, and community organizations throughout New England. And I should add, as everybody's had concerns lately about fake news, after political type news, very often fake news is in the area of health and wellness and disease. Her master's in library science is from Syracuse University. She's a qualified member of the Academy of Health Information Professionals. In other words, outstanding in her field of medical information. Larry Dapsis has a Bachelor's of Science in Environmental Science and Biology at Fitchburg State University and an MS in Entomology at the University of Massachusetts Amherst. His 35 years of professional experience includes pest management regarding vegetables, cranberries, which is helpful when you're in the Cape Cod area, and household insects. He joined Cape Cod Cooperative Extension in 2011 as a deer tick project coordinator and entomologist, and is a member of the Barnstable County Task Force on Lyme and other tick-borne diseases. I hope you will give a warm welcome to our speakers today.
Good afternoon, everyone, and thanks, Sharon, for putting this together. I really appreciate it. As Sharon mentioned, I work with the Department of Public Health, and really from a public health standpoint, the most important role we have when it comes to Lyme and other tick-borne diseases is helping to measure the burden of disease. So, how many people are being impacted by it, and then also to try to help people understand what they can do to help protect themselves. Now that topic sort of overlaps with what Larry's going to talk about later as well. So I'm going to talk a lot about how we try to assess the burden of Lyme and other tick-borne diseases. So what I want to start with is, I think people don't really understand how do I know that? Like, how can I tell you how many people are being impacted by Lyme disease? And the way public health surveillance works is that there are a number of diseases that are considered to be reportable, meaning that they are important enough that information about them needs to be shared with the health department, and your physician and the laboratories that do lab testing are the ones that help provide that information. So what happens is somebody goes to the doctor, they feel like they have, in this case we'll say Lyme disease. The doctor agrees and goes ahead and orders a laboratory test. If that test result is positive, not only is it sent back to the doctor so that they can work with you on treatment, but it is sent to the Department of Public Health, and that serves as sort of record that you are an individual who has sought health care for Lyme disease. Then the other part of it is case investigation. So laboratory tests are helpful, but they're not usually complete enough information for us to consider it, a case of disease. And so either the local board of health or the Department of Public Health will usually contact the physician to get additional information about your case and the symptoms that you had. We then look at the combination of the laboratory test and the clinical symptoms that you had and match it up with a national case definition standard to determine, for surveillance purposes only, not for clinical purposes, but for surveillance purposes only, whether or not we get to count you as a case of disease. So you can see that this is really a pretty complicated system. I think you can imagine there are lots of places where, errors might occur, where we might not get all the information that we need. And because it's subject to a national definition, it also means that it's fairly restrictive and that we don't capture all the cases of disease that are really occurring. And I'm making a point of that, and you'll see why in just a few minutes. So using that system that I just told you about, this is what we have recorded since 1997. And you can see that we went from 300 cases of Lyme disease according to that national case definition in 1997 to over 4,200 in 2013. That was our highest year. And you can see that there are fluctuations year to year, although the general trend was definitely upwards. So again, using that same data, this is a map showing the number of Lyme disease cases per 100,000 population, okay? So it's adjusted for how many people live in an area. And really what I want you to see is that the entire map is green. So the darker the color, it means the more cases that were counted in that area. But for the purposes of our talking about Lyme disease and the risk of tick-borne disease, Lyme disease has been found in people across the entire Commonwealth. And I'm sorry that you can't see Nahant very well. It doesn't show up terribly well on this map. But I promise you, Lyme disease is everywhere in Massachusetts. Next slide. You can also see that we're not alone in this problem. So all those blue dots, this is national data, and so all those blue dots represent Lyme disease cases. And Massachusetts is really kind of smack dab in like a, confluence of blue. And believe it or not, the upper Midwest is actually considered to be a relatively high-risk area for Lyme disease also. Next slide. So again, I'm just going back to this again. This is looking at the data based on the very restrictive kind of public health surveillance methods that are very traditional in public health, and they work very well for certain diseases. I'm actually here to argue today and say that they don't work very well for Lyme disease. There is data, published data, that comes from the Centers for Disease Control as well as multiple different states that suggests that Lyme disease is so underreported, meaning the department gets a lot of cases of Lyme disease are never reported to a state health department, and they are underreported by a factor of perhaps 10, meaning that for every single one of those cases that I'm actually able to count and attribute as a case, there may be 9 more. So instead of 4,200 in 2013, there could have been 42,000. Next slide. So this is a different way that we're actually starting to think about and talk about Lyme disease cases, and we really feel like that this may be a better way to talk about and estimate the burden of Lyme disease in our communities, okay? And so this is based still on the same methods by which we receive information. So we still get those positive laboratory reports, and that's where the majority of our information comes from. We do occasionally have physicians who will send us a report form that says, I treated a case of Lyme disease and I am reporting it to you, even in the absence of a lab test, which is totally appropriate. But so that's where we get data from those 2 different sources. So in 2013, where I was only able to count, 6,000 confirmed plus probable cases, okay, I had over 16,000 individual people in Massachusetts reported to me with some evidence of getting health care related to Lyme disease. Now, not all of those people had Lyme disease, but all of them had either a tick bite or they had symptoms that were consistent with Lyme disease, and they were investigated that way. And I consider that to be a measure of the burden of the disease on us as a society. And so even this 16,000 number falls far short of that 42,000 that may actually be true. But this gives us another sort of bigger picture way to think about the impact not only on people but on our healthcare system for this very, very common burdensome disease. Next slide. So I know this is a Stop Lyme, and I'm all about that. I think that's wonderful. But the bad news for all of us is that black-legged deer tick, it can carry multiple diseases. And so I no longer feel like I can just stop and talk only about Lyme. So I'm just going to mention 2 of the most common other diseases that this tick can carry. And I'm going to tell you that our surveillance data for these two diseases, anaplasmosis and babesiosis, it's much better and probably more complete than it is for Lyme disease. There are many reasons for that I don't have time to go into today, but the numbers I'm showing you here are actually from sort of the more traditional public health surveillance system, but again, for many reasons, they very likely represent a much more accurate picture of what's going on with these two diseases. Unfortunately, they tell the same story as the Lyme disease graph that I showed you earlier, which, although shifted a little bit later in time. And you can see that starting in 2006, the number of cases of both babesiosis and anaplasmosis have risen dramatically. So in 2016, we had over 800 confirmed and probable cases of anaplasmosis. And in 2016, had over 500 cases of babesiosis. Next slide. So these are maps that are similar to the Lyme disease map, but these are for the two diseases, babesiosis and anaplasmosis, that I've just talked about. You can see that geographically they are not distributed across the entire Commonwealth at this point. But I will also tell you that some of the increase in the numbers that we've been seeing are because of geographic spread of these two diseases. And that's exactly what happened with Lyme disease back in the early days. It was, thought of as a Cape and Islands problem, and now it's kind of swept across the entire state. We are seeing something similar happening with these two diseases as well. Next slide. So this may be my last data slide, and what I just want to emphasize to you all is that babesiosis and anaplasmosis, while they certainly occur in our ticks, they don't cause disease in everybody that they get into, okay? There's a high rate of what we call asymptomatic infection, which means you're exposed to it, you never get sick, you never know, your immune system goes ahead and takes care of it, and life moves on. However, the older you get, and I'm afraid that I've just about hit that age where I'm going to have to start worrying about this, but the older you get, the more likely you are to get sick if you are exposed to one of these diseases. And we record fatalities from both anaplasmosis and babesiosis in Massachusetts every single year. Lyme disease has a very different age pattern, and you can see that actually our kids are very heavily impacted by Lyme disease. During sort of your young adulthood, when you're in college, working hard, starting a family, maybe not spending as much time outside, you have less opportunity for exposure, and so the disease rates drop right about then. But then again, as you get older and maybe have more leisure time, you're spending more time outside, more chance of exposure, and the rates of disease go up again. We do not think at this point that this is related to any type of age susceptibility. It's simply opportunities for exposure. Oops, sorry, one more data slide. The other thing that I really think it's important to point out to people is, they talk about, I was coming in here and someone was saying, well, it's the beginning of the tick season. And, in some ways, yes, it is. And you can obviously see that sort of May through October, August, are when we see the majority of our tick-borne disease cases. But I want you to look and see that for Lyme disease in particular, there are cases with symptom onset every single month of the year, and that's because of this nasty tick and how often it can be active unless it's buried under 6 feet of snow, which, as I hear, nobody wants, but unless it's buried under that 6 feet of snow or is super, super cold, the adult tick can be out and active and looking for food. Next. Just going to mention that unfortunately there are more diseases we need to think about. So Powassan virus, also known as deer tick virus, they're two very closely related diseases. This is the only virus that we know of that's carried by this same tick that can cause a problem. It's closely related to West Nile virus, although that's spread by mosquitoes, this is spread by ticks. Just like West Nile virus, in most people we think it probably does not cause disease, but in a few individuals it will end up, the virus gets into the central nervous system and can cause swelling of the brain, encephalitis, and can be fatal. Next slide. So in Massachusetts, we're up to about 13 confirmed cases. I think it is possible that there are more cases of this than we're counting right now. Right now, this is a testing issue. There's not a lot of testing available for this disease, and so it's possible that there are cases that go unrecognized. And then the last disease that I'm going to mention associated with this tick, and I'm sorry, but we can't just talk about Lyme. We have to talk about all of them. Is Borrelia miyamotoi. It was first identified in ticks in Japan, but has since been identified in ticks here. We do have a local laboratory that tests for this in humans, and they are documenting cases of human disease. The good news is that most cases that are reported are relatively mild, and it does respond to antibiotics. And at this point, we don't think it's associated with the persistent symptoms that we can see sometimes with Lyme disease. Okay, so very quickly, I'm just gonna tell you that one of the biggest frustrations I have as a public health professional is that I have no sort of big picture tool that I can apply across communities and across the Commonwealth to make this tick-borne disease problem go away. But there are things you can do with personal prevention. You need to know that ticks are out there, and you shouldn't think about them as being only in specific areas. Unless you're in the concrete jungle, there are probably ticks around. Definitely repellent use can help protect you from ticks, and I know Larry is going to talk a little bit more about that, so I'm just going to move on. What I do want to say is I hear from a lot of people, they have concerns about using repellents. There is some very good information out there that I think can help inform you and help you make decisions about whether Lyme disease is the bigger risk or whether you feel the repellent is the bigger risk. The National Pesticide Information Center is a wonderful resource for that. Make sure that you're doing regular tick checks. Although, as Larry will show you with some show and tell that he brought, this is hard. It's not a perfect solution because some of those ticks are really tiny, but it can help. The faster you find a tick and remove it, the less chance you have of it spreading disease. Some newer things that we're talking about now are, it's been shown that if you throw your clothes in the dryer for 10 minutes on high heat after you come in, may not be very good for your clothes, but it's also not very good for the ticks, and it will kill them. Showering after you come in within a couple hours will help rinse off any ticks that are not attached. Make sure that when you find a tick that you remove it properly. And Dan Wolf is here with a wonderful tool that can help make that a little bit easier. You don't want to do some of the things you read on the internet about, burning the tick or putting Vaseline on it or petroleum gel. I mean, just don't do any of those things. The way to remove the tick is either with tweezers or one of these tick tools, and you want to just grab the tick as close to the skin as possible and pull up gently and firmly, no twisting. Talk to your doctor before you get sick. Find out how they want you to handle it if you are bitten by a tick. Some of them will want you to save the tick, some may want you to test it, and some may want to go ahead and give you prophylaxis to help prevent disease. Talk to them before, not after you're bitten. Don't forget your pets. Next one. And then lastly, I just want to mention as a resource, and there is, I think, a brochure over there. This is the University of Massachusetts at Amherst. The Laboratory of Medical Zoology has a really terrific service that you can send in ticks for identification and testing. And while there are some cautionary notes about whether or not you should use those results for the purposes of clinical diagnosis, I will leave that to you and your physician to talk about. But what is really special about the work that is being done here is that the information is being posted publicly online. And so we're getting good information about what kinds of ticks we have in Massachusetts and what percentage of them are infected. And you can see of the ticks that have been sent into the lab, more than 30% of them test positive for that Lyme disease bacteria. Thank you. Yeah, it's that.
All set? Right. Thank you, Sharon, for inviting me here, and thank you for coming. I've titled this Issues in the Diagnosis and Treatment of Lyme Disease, and Sharon had asked me to try and focus on what's happening and what might be new in these various areas. And we could actually title this What We Know and Don't Know About Lyme Disease as well, emphasizing the don't know about it. I'm going to discuss both diagnostic and therapeutic issues and what we know and don't know about it. And under the diagnostic, I'm going to review a few things about what we know about the clinical aspects, the laboratory aspects, and are there any other adjunctive studies, imaging, that might be helpful. On the clinical, the spectrum of Lyme disease has been described as initially early and then later disease, and it's been revised as early disseminated, and then late disease. And in reality, it's a whole spectrum without any in-between spots. Sometimes after you've been bit by a tick and you go through either no symptoms or you go through, oh, I'm just having some kind of aches and pains or like a flu. And if you have a summer flu, you better think about Lyme disease because there aren't many influenza respiratory viruses. You certainly could get some unusual viruses, but it's one of the things to think about. So it's a whole spectrum, and you might go through that, and maybe your doctor is giving you an antibiotic just in case, and you might not have any symptoms for a couple of months or so. And then you start to have these nonspecific symptoms. Oh, I'm tired, I'm achy, I'm working too hard. Very nonspecific things, and I'll go through that. As far as specific, and this is a group of nonspecific symptoms. And when you look at them, they're all kind of vague. Fatigue, I'm achy, my mind isn't as sharp, maybe I'm upset or I'm depressed, I've got some headache. But a big clue is paresthesias. That means you have like numbness, tingling, unusual, it's raining on my arm, or it's there's like ice picks. And these are not your arms over the shoulder and your arms going numb. These are areas that are kind of, why is this happening? And this could be a clue clinically for physicians to help think, well, I'm having a neurologic type of component. And think of Lyme disease as primarily a neurologic disease. The original description was of the arthritis. And whether that was just part and parcel that it was a rheumatologist who was looking at it, and because you're trained in rheumatology, you look at rheumatologic things. But in reality, the bacteria seem to target the nervous system. And even the arthritis might be a nerve. When you look at syphilis and a swollen joint, it's the nerve that's affected in that joint, and then the body reacts by producing fluid to try and wash it out, if you will. But the point of this slide is that there's all these nonspecific symptoms, but how do you distinguish as a practitioner Lyme from what's being called chronic fatigue syndrome or what's being called fibromyalgia? And when we did our Gulf War symptoms studies, they were based on chronic fatigue syndrome. So it's difficult and it's overlapping. So is the laboratory helpful? Would be nice. In infectious diseases, we're usually spoiled by having a culture of something. If you have a pneumonia, we have some sputum, we can look at it, we find the bacteria, we culture the bacteria. You have a urinary issue, is it a urinary tract infection? You have a wound, is there an infection? We get the bacterium and we do sensitivities on it and we treat. So how nice. It is known, obviously, that Lyme disease is caused by a bacterium. Now, this is not a usual bacterium. And in this country, we're not used to seeing species of Borrelia that are seen, let's say, in South America, that are called relapsing fever, Borrelia recurrentis. This is Borrelia burgdorferi, named after Billy Bergdorfer, who discovered the disease. There is a culture for it, and research-wise, you can culture in the first 1 to 2 months from the bloodstream. After that, it's gone. Well, where did it go? It's not gone. It's not where we're looking. And if you look in the bloodstream after that, you look in the urine, you look in spinal fluid, it's not likely to be there. So this makes it very difficult to prove that somebody has Lyme disease in terms of a culture. So we then rely on tests, antibody tests. And the problem with the antibody tests, in many diseases it's very accurate. But in this disease, there seems to be an ability by these bacteria to disrupt the normal coordination between what are called B and T cells. So you don't necessarily form reliable antibodies in some cases, and in other cases, it's shifted towards one of the immune arms. And what has happened, though, is in lieu of any other testing, it was developed that you do a screening test, and there are newer tests called C6, which is dependent upon a particular specific component of the Borrelia bacteria that are not contained in any other organism. And so when you see a positive C6 test, that means you've been exposed to Lyme. But none of these tests, including the more detailed Western blots, this is a technique, it wasn't developed in the West, it was just called that, and there are components that are looked at, IgM, which are the first antibodies to come up during an infection, and then the IgG antibodies come up later, and traditionally you have an IgM response to begin with, and then as you convert the disease, you get an IgG response. But these have not been that reliable. And there is a conundrum here too, because some of the thinking of the IgM is if it's very helpful in early disease if it's positive. This shows some reactions. But in later disease, somebody said that it's a false positive. Well, they made that up. I don't know how they could do that. And it just shows you the difficulty. So we really need more specific direct detection tests. These are indirect tests. And so they're of some value when they're positive, but when they're negative, you cannot exclude Lyme disease. And if the tests become negative, that doesn't mean your Lyme disease is gone. We just don't have that ability. The DNA testing was hopefully going to be positive. It's positive in very early disease in some cases, but it's not positive. So does that mean you don't have the disease? I don't think so. I think it means we're not seeing where the bacteria really is. In spinal fluid, sometimes people still say, oh, if you have Lyme disease and it's affecting your brain, we'll do spinal fluid, we'll find it. Wishful thinking. It's less than 5% positive. MRI of the brains are done in people who have cognitive difficulties. And then SPECT scans were done for a period of time. They haven't been being done, and I'm a little disappointed in that because it's one of the objective tools you have. It's not totally specific, but as I'll show you in a second. PET scans are now being investigated as a possibility. With our studies, what we found that MRI of the brains of people who have continuing, now I'm going to focus primarily on people who are continuing to have symptoms. They were positive only in about 15%. Positive, what I mean, you have these UBOs, unidentified bright objects, these increased T2 signals as they're called. But these are seen in multiple sclerosis and maybe in some cases of aging, but not necessarily. So they're not there a lot of the time. But SPECT scans, when we did the studies, these are blood flow. It's like you have a bone scan and you're injected with a radioactive substance. This is a radioactive substance, and they follow the blood flow in the brain. And this has been positive in numbers of people, and it affects the temporal lobe. This is what we think is primarily cognition, although there's no one section of the brain that does just one thing. The frontal lobe, which we think about mood changes, and the parietal lobe, a coordination center, but there are other areas. And so when we treat patients appropriately and effectively, the brain SPECT scan changes resolve. So I think that that's been something that I found helpful in my practice, and I've recommended that. Next, please. Now with treatment, we have the issues in early Lyme disease. What do you do if you have a tick bite but you don't have symptoms? What do you do if you have a rash and you don't have symptoms? What do you do if you have a tick bite and symptoms and a rash and symptoms? And so this is still undefined, except there was a study that said that if you have a tick bite and you take 2 doses of doxycycline and a tetracycline type of antibiotic, that in general it would prevent the onset of Lyme disease. But if you do have a tick, save the tick and send it to Steve Rich at UMass Amherst, and within 3 days you'll have a result back, and your doctor can go ahead and say the tick was negative, we don't need to treat you. But you might have another tick that you didn't find. So these are other questions. And when you do have a tick bite, do you do the double dose of doxycycline while waiting the tick results? Do you wait to have symptoms developed? And do you wait for blood tests, which really aren't positive very early? And if you have symptoms, do you give a number of weeks of doxycycline and amoxicillin? And I'm in favor of treating the symptoms until they're gone, not just 10 days, and then if you still have symptoms, I've treated you, you don't have Lyme disease anymore. Next, please. So one of the issues is, where do the bacteria go? How do you know if they're gone? Well, they're going someplace. It appears to me that they go to the nervous system. They might go to the nerve roots, the spinal nerve roots. We have 2 sets of ganglia, nerve roots, sensory and motor. In Lyme disease, it's rare, except for the cranial nerves where you might have a Bell's palsy, or the eye where you might have a palsy, that's even rarer, to have any motor involvement. So people who are in wheelchairs are probably not because they're motor, but they are so fatigued that they can't move, and they're so in pain. So you can get sensory symptoms. And one of the main issues is we need to establish whether they're there or not, so both doctor and patient can be more comfortable with managing the patient about further treatment. How do they cause the disease? Not their physical presence, they're minute things. So either they have to directly be toxic, causing some direct toxicity, or there's some reaction, and it's probably, as in most cases of infectious disease, a combination of both. There is some toxic kind of product that the bacteria has, and then there's a reaction by the body, and you get your symptomatology. Is there autoimmunity to explain what's called post-treatment Lyme disease or chronic Lyme disease? I think the evidence is very weak, and even if it was there, what's driving it? The persistent infection? Or is the infection not there, but you have detritus and you have some reaction against the detritus? Well, for how long are you going to have detritus? 2 years? I don't think so. So there's more and more evidence for persistent of the organism. In Cornell in the 80s, there was some nice dog studies with beagles where they infected them, treated them, and they used DNA analysis. In those cases, it worked very nicely that showed that it came back. And now there's some mice studies that show persistence in collagen areas, and the more recent studies out of Tulane where they infected sets of macaque monkeys and treated them, and then 8 months later they were able to diagnose it. And you know how they diagnose it? In the same way that a few little human studies have been done in Tufts, where they put ticks onto the monkeys and the people, and the ticks were able to recover the bacteria. And so this is, I think, exciting information. It's probably not a clinical tool right now that I have ticks to put on you to see if you have Lyme disease. So let's go through for time considerations. I just want to talk a little bit about the persistence. How do the bacteria persist? And there is recent information that there is a system in many bacteria. This hasn't actually been shown for the Lyme bacteria, but a number of strep E. coli staph where they have a system inside their cells. They don't get truly resistant to the organism, but they're able to take the hit or to decrease the impact of the hit or to go dormant until the antibiotic goes away. And then they become more active if certain interventions, stresses, whatever that is biochemically, or intercurrent events. So this is a whole exciting area that I'm pleased to say that there is more and more research that is coming in that area. I think I'm going to conclude here. Keep going here, and we can answer questions later. Keep going. Keep going too. There are differences in antibiotics. There's some that are sensitive in the test tube, but getting that antibiotic to the site of activity has always been a part of infectious disease and pharmacology, knowing how the drug gets to where it needs to go. And the same thing with Lyme disease. Some of the early studies used doxycycline, where I learned very early that for continuing infection there isn't enough doxycycline that can get to the tissue. So I used tetracycline, a very old antibiotic, that gets to tissues better, and it works much better than doxycycline. And I hope people are beginning to appreciate that. And then there are interesting other aspects. An antibiotic isn't just an antibiotic because that's what it does, but it has to do special things. In the case of the erythromycin antibiotics, and there are new ones called Zithromax, Biaxin, clarithromycin, and Zithromycin, and they're very effective in the test tube, but you give it to people and it doesn't do anything. What's up with that? And we know that it can get into all kinds of cells and tissues. And it turns out that when you look further at patterns of how bacteria get into cells, they get into certain compartments. And some of the bacteria get into a compartment and they take over that compartment. It's like a kid in your house, and they revise the room, get out, stay out. And these bacteria are able to do the same thing. And they lock themselves in that compartment. So you need to be able to figure out how to get in that compartment or change the activity of it. And that's what's happened with these antibiotics. If we added another agent that changes the pH inside cells, it works. Keep going. And the longer you've been sick with Lyme disease, the less likely you are to be cured or improved. Next. And whether there are hormonal explanations as to why women have a harder time being cured or improved compared to men remains to be seen. And then there are these other treatment issues which we can discuss later. To help people, some people have, and this is all due respect to naturopaths and holistic people, but let's give them vitamins, let's give them antioxidants. And it turns out you're probably, in the case of antioxidants and B vitamins, helping the bacteria survive. Because the body is trying to starve it of its nutrients. Last slide then. We need to look at the guidelines that have been created because they have been overstated in the interest of helping doctors and patients who might be confused by the data. Well, that's a bit condescending in my estimation, and we ought to recognize our limitations of what we know and what we don't know. And we need to be careful about what treatments we give patients because each treatment, including antibiotics, have potential toxicity. But I think if you recognize those, you can deal with it. We need direct detection tests, and I'm happy to say that we're seeing grants now being submitted for direct detection and for better diagnosis so that the doctor and the patient. We need more controlled trials, and we do need vaccines. Thank you.
Okay. Hi. So as a librarian, I can tell you that there are questions that people will ask librarians that they won't ask their doctors. And that's why today I'm going to talk about miracle cures and searching for information on the internet. So as a medical librarian, my first go-to website when I want to help patients and their families is a website that's designed by the National Library of Medicine called Medline Plus. So I do have a handout in the back of the room, but the web address for that is medlineplus.gov. And I use this almost like you would use Google. There's a search box up in the corner that I put the disease or the condition in, and then I hit go. And I'm going to get a list of results. And it's like Google, but it's better than Google for two reasons. The first reason is that there's no advertising on it. There's no pharmaceutical advertising on it whatsoever. The second reason is that the hits that you're getting, the results that you're getting, are not determined by a Google algorithm. They're determined by librarians down in Bethesda who have chosen excellent articles and websites for you to look at. Okay. This is all about science-based medicine. Go ahead. But what about alternatives? So when I was preparing for this, on Thursday, I was telling my colleagues in Worcester, and they said, "Oh, did you hear about that girl?" And I said, "No, what girl?" And they said, "It was in the news this week. This girl got Lyme disease on Cape Cod, and it went undiagnosed, and when it was they finally figured it out, they tried treatments and they didn't work. And so the mom got on the internet and learned about this treatment protocol in Germany where they heat the body up to 108 degrees and it like cooks away the Lyme disease." And I said, "Well, no, I didn't hear about that, but it sounded very familiar." So I don't know, how many of you, have any of you heard that story this past week about that girl? Okay, you did hear that story. Are any of you familiar with Bob Marley's story with cancer? Okay. So in 1977, Bob Marley was kicking a soccer ball around in his bare feet, and he developed an injury on his big toe. And this developed into a sore that didn't heal. And like a lot of us, he didn't go to the doctor until it got really, really bad. And by the time he got to the doctor looked at it and diagnosed it as a type of skin cancer that people of color are very susceptible to. And at that point, the doctor suggested that he amputate the toe. Now, amputation was against Bob Marley's spiritual beliefs, and this is way before the internet. This was like in the early 80s. And but as people sought out a cure, and they found one in Germany, called the Eisel's combination therapy. And once again, part of the therapy was to raise the body's temperature to 105 degrees. This journal article said that they did this through the use of vaccines. I don't know how that would possibly work, but this was the deal. And there was also a regime for diet and oxygenated blood transfusions and such things like that. Unfortunately, it did nothing for Bob Marley's cancer. He ended up coming back to the United States for some treatment and ultimately going home to Jamaica to die. So miracle cures. One of the things that I didn't tell you about that girl's story is that the family had set up a GoFundMe, one of those GoFundMe websites, and they had to raise $62,000 to bring their daughter to Germany for this treatment. And it's too soon to say whether or not it's worked. So what is the evidence? Go ahead. So when I have not heard, my colleagues kind of threw this in my lap on Thursday, so I wanted to include it. But when I was looking for natural remedies for Lyme disease, I found many websites out there, and a couple of them, more than one, were authored by an MD, a doctor who had had personal experience with Lyme disease and had developed regimes for how to treat Lyme disease naturally. And all of these treatments included, well, some of them included dietary changes and exercise or meditation and that sort of thing, but they also included the use of supplements. And these were the supplements that I identified in these different websites. I also read a tongue-in-cheek article, an op-ed from the New York Times that said really the best natural remedy for Lyme disease is wolves and cougars. That if we create a friendly environment for wolves and cougars, they will eat the animals that host the ticks that carry the Lyme disease. So again, as a medical librarian, my go-to place is medlineplus.gov. And I will tell you, if you put Lyme disease in that search box and hit go, what you're going to get is recommendations from the CDC on how to treat Lyme, which is, you know, most likely what you're hearing in your primary care doctor's office too. So I'm going to give you three recommendations for using 3 different websites for looking for information about these alternative ways to support your body. Because we are learning something about integrative medicine, it's clearly something that people are very interested in. And there is evidence about a few things about integrative health or using alternative ways of healing along with standard medical care. The first thing we know is that, putting Lyme disease aside for a second, thyme is a great healer. When my kids were little, they got the amoxicillin right away for ear infections, and now my grandson, my daughter was told to wait for a couple of days to see how things would resolve on their own. Back pain, just the passage of time will do a lot. The body does rally to heal. Another thing that we know is that the rituals of healing are very powerful. And one of the reasons why alternative medical practitioners or alternative health practitioners get such high marks from their patients is because when you walk into their office, they sit with you for like an hour and listen to your journey. And that really is powerful. Another thing that we know is that chiropractic, massage, and acupuncture are all relatively safe if you're using a qualified practitioner. So if in part of what you're trying to do for yourself or your loved one is to go to a chiropractor or a massage therapist or an acupuncturist, it's not going to hurt. Another thing that I like to mention is that cognitive behavioral therapy or talk therapy has been shown to be an effective adjunct to physical treatments no matter what you're dealing with. If it's an illness, an injury, or trauma, having an opportunity to talk to a therapist or participate in peer-to-peer group support is helpful. Okay. But please, before you try herbs, vitamins, and supplements, please learn about the potential dangerous or hazardous or troublesome interactions that might happen with other drugs that you might be taking. Maybe you have high blood pressure, maybe you have asthma, or maybe you take certain herbs or supplements on a regular basis. Please learn about the interactions, and I'll show you 3 websites that you can use. Go back one more second. Talk to your doctor, don't just talk to your librarian, and listen to your body, okay? All right, so we don't have time for this, but I did, on the handout, I included the web link for this talk. This is Ted Kapchak. He's a professor or a researcher at Harvard Medical School, and he studies the power of placebo. And he's been doing a lot of really interesting, this is a TED Talk. I don't know if any of you have watched or listened to those on NPR. This is a really great 17 minutes about his work on placebo and the power of belief. Okay. Another fun little YouTube channel to see science-based videos, and these are usually very short, and the presenters talk really fast, is something called SciShow. And the reason I put this slide up here is because belief really carries a long time, even beyond when evidence has proven otherwise. So how many of you have heard the use of cranberry juice for either preventing or curing urinary tract infections? Well, there's actually absolutely no evidence, and they've studied it, and there's no evidence that it actually works. But the belief is persistent, and you could still maybe go into a doctor's office and still hear that. So again, my go-to place is Medline Plus, but I'm going to tell you, if you just throw, like I said, you throw Lyme disease into that, you're just going to get the CDC recommendations. I'm not saying they're bad, but if you're looking for alternatives, searching on Lyme disease is not the way to go with Medline Plus. You could put the name of one of the supplements into that search box, or you could click on that button that says drugs and supplements. Okay. And so if you click on the drugs and supplements button, you're going to get an A to Z list of supplements. And I went with this supplement, I don't know how to say it. It started with A, it was top on the list. But when you go to Medline Plus to look it up, you're going to find out what it is and what the science says about how it's supposed to work, what we know about the biology of it, and if there's any interactions with any medication you might be taking, or any foods that you eat, or any other herbs or supplements. It's also going to give you, what a standard dose would be. Okay. The second website I want to tell you about is from the National Center for Complementary and Integrative Health. This is part of the NIH. And in this website, so the website address is up at the top there. And for an example, I gave coenzyme Q10 right here, which was one of the supplements that was listed on those websites that I looked at before. And again, by going to the NIH, you're going to learn what do we know about this supplement, what is the effectiveness of it, as far as we know, if there are any warnings or safety warnings. And it'll also tell you if there's any current research being done by the NIH on these particular substances that you might be looking up. The last database that I absolutely love, but it's not freely available online, the first two are. This one's called Natural Medicines, and when I was working at Bay State Health, which is a hospital in Springfield, Massachusetts, our pharmacy department wanted us to purchase this database for their use in the medical library. And I just fell in love with it. And this is an incredible resource if you really want to dig deep and learn about natural medicine. You can get a personal subscription, which is about $13 or $14 a month. You can do it month to month, or you can do it annually if you're really into it. Or you can contact a librarian and we can help you look up the information that you might need. And I'm going to show you why I love it. This is an evidence table for cat's claw, which is an herb that has been used historically for arthritis. And so for the substances that Natural Medicines is looking at, it gives you evidence tables, which at the very top you can see that this one is it was a systematic review published in 2010. It looked at 4 trials, and it did see statistically significant improvement in pain of arthritis. And at the far end, it gives comments of what the studies were about. In this case, they studied men. They gave them a certain amount of this supplement for so many weeks, and these were the results. This is just the top hit of this evidence table. If you scroll all the way down, you would see many more, and then you would also see the citation to the journal articles that they're discussing. Okay, I do want to let you know that the University of Massachusetts is where the Commonwealth's Medical Library is. As taxpayers, you do have access to the library. Unfortunately, because of licensing agreements, we can't make those resources available to you freely online. If you got yourself out to Worcester, you could walk into the library and use them, or you can instead email me or contact the librarians right here. And if you're interested in a particular a supplement or something, we can take a look and get that information to you. Okay.
Larry, before you plunge in, I know, he's ready. I just want to remind everyone, if you have a question, you can write it down. We do have some index cards you can give away. Can I ask you to do that? Thank you. I also want to let you know that we have a couple of other people here who are happy to answer your questions. Sheila Statlander is a psychologist, and she knows a lot about the emotional aspects of Lyme, what Lyme and other tick-borne diseases do with children, and some of the legislative aspects. She helped create some state law that's now may be of some assistance to you. Also, I have John Kulan in the audience. He is Nahant's health agent. So if you have questions of a more regional, local nature, John is here as a resource. We also have 2 organizations here that are involved with tick control and prevention. So afterwards, please avail yourself to those resources as well. And now, I'm going to give this over to Larry. Thank you.
Are we on? Okay, we're on. Margaret, would you hold those 2 vials for me? And don't open them. They're dangerous. Thanks, Sharon. Well, I can't think of a better way to spend a Sunday afternoon than by having a very robust discussion of infectious disease. It certainly works for me. I do this kind of thing all the time. I do this about 50 or 60 times a year. Title of my presentation is Deer Ticks, One Bite Can Change Your Life. Hopefully most of you in this room subscribe to that already today, but hopefully at the end of the time we've had together, you will actually believe this. No, I didn't advance the slide yet. It's the secret signal, okay? All right, way ahead of me. Sharon, I think it'd be great if someone asked me, Larry, how did we get into this fix? I mean, anybody at all. That is a very astute question, which I want to delve on right now. There's some interesting ecological reasons for doing this, I mean, talking about this. So how we got here? Well, if you look at when this country was settled hundreds of years ago, one of the first things we did was we clear-cut all the forests to make homes and create farmland. And then we had forest regrowth, and people in the cities began eventually moving out into the suburbs. And what we've done is we've actually fractured the forest, and that's had a huge impact on why we're in the fix we are today. Come on, you gotta play along. Yes, keep up. So if you look at land use management patterns, this is West Falmouth. And this shows West Falmouth back in 1951 compared to 2009. And you see this forest fragmentation quite clearly. We've been cutting up forests. I mean, we're reducing acreage overall, but we're cutting it up into smaller pieces. Sharon, need you. Okay. And this is a great picture, satellite picture, of just a few miles up the road. And you can see this quite clearly. You've got these little patches of woods compared to expansive forests. All right, this is really important because as you chop up the forest, there are creatures like the mice and the chipmunks and other things. They basically thrive in these conditions. They actually really love it because they can do their business and expand their populations. And the important thing about the rodents here is that these are the primary reservoir hosts for the Lyme disease bacteria. So the mice, the chipmunks, the squirrels, and things like that, they harbor the Lyme disease bacteria, and so it's like microbial ping pong. They have the ability to transmit that infection or the pathogen back into the tick population. Top tier predators. Yeah. Things like fox, they are one of the best predators of things like mice and other small furry animals that are of interest. The impact of forest fragmentation is that you get down to a certain size. No, back one. You lose your top predators. They don't have enough territory. So that's the reason that these other animals that are very important in this very complex ecosystem are allowed to flourish. Now we can move on. Maybe I'll check a different signal. So, interesting thing, if you expand the ecological landscape, the mice, the ticks, and acorns, they are all related. Acorns, why the heck is that important to us? Well, acorns are the primary fuel that drives this whole ecosystem. And that's one of the reasons I love being an ecologist so much, because a basic tenet of ecology is that everything is connected. You can't tug on one thing without impacting possibly a cascade of events. The way this plays out is that as oak trees, which is a dominant species in our forests, if they have a year where there's huge acorn production, the following year you're going to get an upswing in the mouse population and other rodents, and that's going to have the ability to feed the tick populations and make them higher. And the same thing goes the other way. As acorn production goes down, you see a concomitant response in the rodent populations. So it's a very interesting ecosystem. There was another thread I was going to touch on here. Oh, the other thing, believe it or not, as mouse populations go up, gypsy moth populations go down. Why is that? You know those little cocoons, the brown cocoons that gypsy moths you see on the side of trees in June into August? Well, to mice, that is movie theater buttered popcorn. And so they love to chomp on those things. All right, let's talk about a couple of the players you might interact with, unfortunately. This is the American dog tick. A lot of people also call this the wood tick, and I consider this more of an annoyance than a public health threat, even though they can vector the pathogens that cause Rocky Mountain fever and tularemia, both of which can be quite serious, but they're very uncommon in Massachusetts. The principal player here still is the deer tick, and as Katie pointed out, the proper name for this tick is really the black-legged tick. Deer tick is a misnomer. This thing has been documented to feed on 125 different vertebrate hosts. So this is a very complex ecosystem, a lot of moving parts. All right, winters. I get this question every spring from the media and a lot of other people. Larry, we had a horrible winter. What did that do to the tick populations? And my pat answer, without even having to think about it, is absolutely nothing. It had nothing, no impact on the tick populations. People associate a hard freeze with mosquito season being done, and it is, but not so with ticks. And harsh winters is a relative term here. The winters in eastern Massachusetts really aren't all that harsh by comparison. When I was at Ocean Spray Cranberries, I spent 24 years traveling to Wisconsin, where I went by the name Misha, okay? Wisconsin has real winters. 25 below zero for extended periods of time is not that unusual, and deer ticks are just happy, 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 and Wisconsin is quite endemic for Lyme disease. And there's an interesting reason for this. Ticks synthesize a chemical called glycerol. Well, what the heck is glycerol? It's antifreeze, okay? They are very, very good little chemists. And the purpose of the glycerols, it prevents ice crystal formation in cells, okay? And what they also discovered, I'm going to try not to blind you with this laser, Katie. What they discovered is that Lyme disease bacteria also feeds on the glycerol as a source of energy for itself. So this is one perfectly engineered little package. All right, protect yourself. Phase one, we have a 3-phase plan we talk about. Protect yourself, protect your yard, and protect your pet. So we're going to cover the first two, and pet protection we can talk about offline. My business, Sam, cover your ears right now. My business is to take business away from doctors and hospitals, okay? I am in the family protection business, all right? And I take that seriously. So here's an average family on Cape Cod, okay? This is obviously Woods Hole, okay? And they need protection from tick-borne diseases as well as from themselves. Okay, the risk, as Katie pointed out, the risk of infection is year-round. In fact, Katie, it's almost like we talked about these presentations together so that we wouldn't really overlap, but we would complement. Boy, I just go figure. And so the risk of infection is year-round, but the greatest risk of infection is not from the adult stage ticks. Those are the ones that are active from the fall through the spring. There's still a few of them out there right now before the nymph stage come out. But that's a larger stage of the tick, and you're more likely to detect that bite, even though on average we find that 50% of that stage carries the bug that causes Lyme disease. The greatest risk of Lyme disease is really from that nymph stage tick. They're active from May, but they're probably going to be out a little bit earlier this year based on the winter, and they'll be with us until early August. And again, in our research, we find that on average about 25% of them are infected, but that's a much smaller stage of the tick, and that bite is more difficult to detect. Okay. What I'm going to do is pass these vials around. These things that look like they're the size of a poppy seed are nymph stage deer ticks. Be careful and don't open that. You can hold it. Couldn't resist, I'm so juvenile. And pass that around, please. But it points out the fact that something the size of a poppy seed just might look like a freckle on you, and you might not remove it. So it's, and that's why it's responsible for 85% of all tick-borne illnesses. All right. Katie mentioned some of this, and I'm going to dive into it a little deeper. I talk a lot about repellents with people, and repellents come in a couple different flavors. All right, so you have this group up here, like the DEET or the DEET alternatives, like picaridin or oil of lemon eucalyptus, and these products are for treating exposed skin, and they can be quite effective as a tool. One more, one more, one more. And then we have this other group, all natural products, okay? There's a big difference. There's a huge difference between these two groups. The group up here, these are EPA registered. So if it has a label claim that it will repel ticks and mosquitoes for 6 hours, there are data on file at EPA to support that claim. These all natural products, they're EPA registration exempt. They don't have to prove anything that they work at all. It's all anecdotal. And actually for these all-natural things, which really resonate with the soccer moms and soccer dads that, you know, I'm using an all-natural product for my kids and aren't I a good parent? Well, a number of these active ingredients I found out are known human allergens, and there are documented cases of these products interacting negatively with sunscreens, okay? So I wish the Federal Trade Commission would swoop in and just stomp this group into nanoparticles, because those products are so misleading. You're being led into a false sense of security, absolutely. All right, the other repellent I've done a lot of work with contains the active ingredient permethrin. And this isn't for skin, this is for treating clothing, so your pants, your socks, and treating footwear is mission critical. And the reason for that is that those nymph stage ticks that we're passing around, they're down in the leaf litter. The first place they attach to are your shoes. Hopefully you're wearing shoes instead of flip-flops. And what I found is that it's not only repellent, but if you put a tick on a permethrin-treated fabric surface for 60 seconds and then put it on a clean surface, on average that tick is dead in 9.5 minutes. So it is a real attitude adjuster. In my experience, this is the most effective tool in the box, hands down. I wear this year round, and since I've been doing this for the last 6 years, I've not got a single tick bite, and I have no need to use Dan Wolf's little product. The biggest problem on the Cape was finding it. So if you knew about it, the only place on the Cape you could get it was Eastern Mountain Sports. So I spent time with all the garden centers on the Cape convincing them to stock this product. And so I meet with the store managers and I say, you got the product? Are you moving it? And it is flying off the shelf. The word's getting out there. Funny thing, after one workshop, a woman called me and she said, Larry, I want to just tell you I bought a whole case of permethrin, which is like $130. And as she's talking, I was thinking to myself, this lady really drank the Kool-Aid, so to speak. And then she told me she was 83 years old and was going to use them as stocking stuffers for her adult children because she loved them. And I thought that was such a sweet, sweet story. This particular product, after you apply it, it'll keep its activity through 6 washings. That's because permethrin's really not that water soluble. The other way you can do this, you gotta pay attention, gotta be fast. You can buy pre-treated clothing with permethrin from Insect Shield. You can find insect repellent clothing under other brands like Orvis and Bean and REI, but Insect Shield's in the private label business, so if you bought it from Bean, it all came from Insect Shield. They've got a process where they really stick this to the fabric. It will keep its activity through 70 washings, basically the life of the garment. And it's a good product. I've used it in the field. The first time I bought a pair of khakis, I went wandering into the brush, watching the ticks attached to me, and they're climbing. I'm kind of laughing because I think I know what's going to happen. And after about 30 or 40 seconds, they're just lifting their legs alternately, like they're getting a hot foot. And after about another 30 or 40 seconds, they dropped off. It was like a tick water slide. It was a lot of fun. The other way you can skin this cat is you can send your clothing to Insect Shield. They will treat it, send it back to you with the same 70 washings claim, and if for another $3, they'll embroider Insect Shield in the waistband, and you can make your own tick protection fashion statement. How slick is that? All right, this is the elephant in the room slide, because when I'm doing these, soccer moms and soccer dads look at me like I am absolutely insane. They're saying, Larry, you're telling me to put my kids in clothing treated with a synthetic chemical pesticide. And I nod my head because I refer them back to a slide Katie showed. Kids age 5 to 9 have the highest incidence rate of Lyme in the Commonwealth. So whatever we've been doing up to this point is not working. We have to do a better job, absolutely hands down, protecting our kids. So what I do is I'll spend time walking people in off the window ledge about permethrin toxicity. We'll go through the whole profile. It's over 2,000 times more toxic to a tick than a person. That's because people are big, ticks are little. It doesn't take a whole lot. We're using a low concentration product, basically 0.5%. EPA established a position that reasonable certainty that permethrin-treated clothing poses no harm to infants, children, pregnant women, and they've extended this to nursing mothers. And their criteria certainly would be conservative. And the reason for this, it's absolutely key, is that permethrin has very low skin absorption. There are other classes of insecticides where once it touches your skin, it's mainlined into your bloodstream, but not so with the pyrethroids like permethrin. And whatever small amounts absorbed is actually metabolized very quickly. They discovered that the metabolites show up in your urine just a couple hours later. National Academy of Sciences, that is not a lightweight group by any stretch. They were wondering about long-term effects. So in their evaluation, they assumed people were wearing permethrin-treated everything, 18 hours a day, every single day, for 10 years. And when they rolled up that aggregate exposure, they saw no reason to expect an adverse effect. And the last thing I point out is permethrin is the active ingredient that you would use to treat an infant for scabies mite or a kid for head lice. So the way I talk about this to people is that when I look at what I think is a relatively low risk cup for permethrin exposure, and I weigh that against the consequences of one of these tick-borne diseases, hands down, it's easy math for me. Pardon? Oh, it's okay. The question is about the product. It's actually a synthetic chemical, permethrin. Natural pyrethrum is an extract from a kind of daisy they grow in Africa, Kenya and other places. And so that particular molecule breaks down very quickly in sunlight within hours. It's very effective, very fast knockdown, but it doesn't last long. So chemists looked at the chemical architecture of natural pyrethrum, and they made adjustments to it. They added, you know, like a bromine molecule here, atom here, and some other things, and a double bond there. And so they've stabilized it so that it'll persist for a lot longer. So it's based on the chemistry of that natural product. All right, let's look a little bit about vitology, okay? Here's a tick's head. Here's a tick's head under a microscope, okay? Looks pretty formidable. These things on either side of the tick's head, those are what we call palps. That's what the tick uses to taste you and see if you're worthy of becoming the blue plate special, okay? If you are, it'll take these appendages here. These are chelicerae. These are like little scalpel blades with hooks. And what they will do is they will make an incision, hook in, and pull. It's kind of like doing the breaststroke, okay? And it'll drive this mouth part deeper and deeper and deeper into your skin. So next. That's what the beak of a tick looks like under a microscope. So it's fairly long in relation to the body size. People call me and say, Larry, I pulled the tick off, and the head is still embedded in there. Well, they can't physically fit their head in, but that mouth part is pretty long. And it's no worse than getting a wood splinter, a little neosporin, it'll dissolve. But here's what makes it difficult actually to extract a tick. It's got all these nice recurved barbs. And the other thing it does is that when a tick attaches to you, it doesn't start sucking blood immediately. First thing a tick does is it spits. They've got no manners at all. And tick spit is absolutely fascinating. There's thousands of different chemicals. And some of the chemicals are like anticoagulants, keep the blood from clotting, vasodilators, increase the flow of blood to the point of attachment, and things to deaden your nerve cells, because that tick wants to be very stealthy and undisturbed. A tick might need to feed for 4 or 5 days till it's full repletion. Then it'll secrete an enzyme, dissolve the glue, and back itself out and go on its merry way. Okay. Also, phase 1 game plan, protect yourself. Katie already covered off on tweezers and proper removal technique. Very nice. We'll take it to the next step. Record the date. That's important. If you knew you get a tick bite, record the date, because some of these diseases don't show up, quickly. It may take some time before. So if you know when you were bit and then you're not feeling good, now it's time to have a conversation with your doctor. I ask people if they save the tick. Invariably no, except for a few people that kind of tape them to an index card on their refrigerator, kind of like a little tick mortuary, a lovely sight. What do you think most people do with their ticks? Survey says the flush, #1 answer. But I've also had a few people tell me, Larry, I just put that little thing in the microwave for a few seconds till it popped. So some people take a very big form of revenge on these. As Katie alluded to, there is a reason for saving the tick, that you can get that tick tested at the University of Massachusetts. You go to tickreport.com, there's an online submission process, and they guarantee that you'll get those results in 3 business days. Sharon. Okay, here's an example of a tick report, okay? And so this is a 3-year-old boy in Norwell, had a tick attached to his head, and Sharon, if we look, 2 clicks. One more, yeah. They will also send you back a picture of the tick that they've identified as the deer tick, and that thing is fully engorged. That tells me that that was on that kid's head for 4, maybe even 5 days. I'm not even sure how that happens. And we see a couple interesting things in the report. This tick tested positive for Borrelia burgdorferi, which causes Lyme disease. And as Katie would attest to, that if that tick was attached for 24 to 48 hours, the risk of transmission of that pathogen ramps up very quickly. So it's highly likely this kid was going to come down with Lyme disease unless the doctor intervened. Oh, no, too quick. And the other thing here is that the tick also had Babesia, which causes babesiosis. So even though that's not very common in younger people, doesn't mean it doesn't happen. The other thing this points out is co-infection. Very important thing we're learning. We're seeing a lot of this, that these ticks can contain 2 pathogens, 3. We've even seen ticks that contain all 4 of the major pathogens, okay? So it's something, the database that's being developed here. In fact, if you go on tickreport.com, you can search by zip code and look at what the ticks they're finding in the ticks in your neighborhood. So it's very good. In fact, the medical community on Cape Cod is now starting to embrace this and basically ask people, well, do you have a tick report? Which is really, really good. And because doctors might not know what the what combination of these things might look in terms of a clinical presentation. So it kind of makes the picture a little more complex. All right, phase 2, protect your yard. All right, in a typical house lot situation, you're not going to find deer ticks out in an open lawn area like this, all right? Short grass, direct sunlight, low humidity, that is just a very hostile environment for deer ticks. But you get into transition areas, the edge of the lawn that might be in the shade, to brush and shade trees, leaf litter, high humidity, that's where you're going to find the ticks. But if you think about those environmental conditions, woody ornamental plantings at the edge of a house, shade, some leaf litter, high humidity, you can easily find ticks there as well. As a two-phase action plan, I'm a big fan of perimeter yard sprays, okay? And there are products, and we were chatting, who's the gentleman from the pest control company in the back? Yeah, we were comparing notes earlier about he does this as a service, and we're seeing a ramp up in businesses. In fact, I'm being brought in to train workers from some of these companies to make sure they're doing it the right way. And for our strategy, personal protection and then perimeter yard sprays, mid to late May and late June, that pretty much covers that NIMP stage window of activity, and then again mid-October when the next generation of adult stage ticks are out and rocking. And there's another product on the market you may or may not be familiar with, these Daminex tick tubes, okay? The idea of this is that these are cardboard tubes that contain cotton balls treated with permethrin. And the idea is that mice will steal the cotton balls. Next. Yes, I know. I saw them. They'll take it down to the burrows. Next one. And they'll use it as lining for their little dens. And so basically they self-treat and they're tick-free. And it's kind of a sexy idea. In fact, you know, this is the product of choice for the people on Nantucket and the Vineyard, where they have the highest incidence rate of Lyme disease in the visible universe. So I looked into this product, and there were 2 really, really good studies done on this. Multi-year replicated trials, one in Connecticut, one in New York. I read the papers, spoke with the researchers, and they both came up with the identical conclusions. This product had no material impact on deer tick nymph populations. And the reasons for this, they both came up with similar reasons, is that mice aren't compelled to steal cotton balls just because they're there. And not all tick-carrying animals steal cotton balls. Chipmunks don't, squirrels don't, birds don't, raccoons don't, possums don't. So unless your yard is solely inhabited by white-footed mice that have an obsession for cotton balls and respect your property boundaries, there's no reason to expect this product to work. So it's one of my professional goals is that this product goes away just because nobody's buying it anymore. All right, and there's a lot written about wildlife and habitat management. All right, deer fencing. Well, basically the deal on that through research is that only when you fence off an area of 15 acres or more, that's only when you start to see a reduction in tick populations. Bird feeders, next. Pruning trees to let in more sunlight to the bottom of the canopy. And moving wood piles. This person is actually more concerned about snakes than ticks. When I looked into these things that are kind of boilerplate recommendations, there is absolutely no scientific evidence to support doing any of those. So I tell people don't waste your time. Do the permethrin clothing and the perimeter yard sprays, and that should be the game. All right. So what we're looking at here is a situation where we have a high degree of risk, but the silver lining here is that we have the tools available to manage the risk, okay? And the things I've outlined here today are things you can implement on your way home today, okay? So we're trying to make this as simple as getting up in the morning, getting dressed, brushing your teeth, having breakfast, and go to work. and also protect yourself from tick-borne diseases. So that is it.
Sure, absolutely, please. We do have some very intelligent questions, so I want to pass them by you. This first one, how prevalent are disease-borne ticks in Nahant? And so it can come to you, or certainly throw it to John, if need be.
When I looked at the database for tickreport.com, there have been no ticks submitted from Nahant. But the neighboring towns, Beverly, I think, and Lynn, there were a number of ticks on record. And what I saw there that for Lyme, about 40% of them were infected with it. There was a lesser percentage, about 10% with anaplasma, and less than that with Babesia, and we didn't see any Miyamotoi. So it's representative, I think, of what we see on Cape Cod. So it's nothing, you don't have, it does vary even on the Cape. There are areas that I've done surveillance that have very low tick densities year on year and very low rates of tick infection, and other areas where huge tick populations and the places are just scary based on the testing data we've seen.
Yes, John?
We were discussing just this approach to infectious disease surveillance and control before the presentation got started. And it's very important for people to recognize that tick-borne illnesses are endemic. They're spread out all over. And Nahant has 1 square mile, and it is representative of other areas in Massachusetts, be they coastal or forest areas. We have ticks, we have mice, we have the larger animals, all of which are illness hosts upon which ticks feed. And we are merely another animal. And when ticks come in contact with us and the bacteria is exchanged, we are susceptible to the illnesses that they carry. So it would be a disservice really to say what number of people in Nahant's population came down with a tick-borne disease, at least identified as that, over a particular period of time. The most important thing I think has been brought out by each of our presenters here today, and that is recognize that it is here, it has been here for a long time. We should count on it being here for a very long time, and we should not shun the outdoors, but embrace it. And how a tick can stay on a person for 4 or 5 or more days sounds pretty amazing when we are encouraging people to not just do tick checks, but do our normal personal hygiene.
Okay, along that line, the next question has to do with where's the lab to mail a tick that can be tested, and I think you saw that there is a handout on the table that includes various places, including UMass Amherst, where you can send them. What I'm working on now actually is to see if we can put together another grant where we can reduce the price with UMass Amherst. They've done this Cape Cod and other places where they underwrite through the towns, through a grant, whatnot, that it would cost you a smidgen to send it. I think now it's about $50, $60.
For a full panel test at UMass, it's $50 test. We've received grants for the last couple of years from Cape Cod Healthcare to subsidize that, and so right now it's $15. Basically the cost of a pizza. And for tickreport.com, if you go to the website, there is a chat function if you get stuck or have a question, and they monitor that thing like a hawk. This laboratory, they are extremely customer service focused.
I didn't have a chance to. What container do they recommend when you get a tick?
Sure, sure. A lot of people ask me, do I have to put this in vodka in a glass jar? And because that's just a popular way of preserving ticks on the Cape, I found out. We recommend that you just put the tick in a little snack-sized Ziploc bag. It doesn't, and don't put a wet paper towel in with it because that'll cause the tick to decay. We want it bone dry, and that tick can be dead for hundreds of years, and they can still extract the DNA and do the test. And because once they get the tick, they basically put it in a mortar and pestle and grind it up like they're making tick pesto. Then they do the extraction for the DNA and find out who's in there.
This next question for Dr. Brown, discussing the meat tick allergy that is coming up. Is this becoming more prevalent in the area? Should there be something on the state website to warn people? Could you speak to that a little bit?
Yeah, so I think what that's talking about is a relatively recently recognized association between the bite of at least the Lone Star tick, which is kind of newly emerging in Massachusetts, although it is possible that there are other ticks involved, and then the individual developing an allergic reaction to red meat, essentially. This is something that's been going on and been known in Australia for years, but we're starting to recognize it more now in the United States. So that is not an infectious disease, and therefore the occurrence is not reportable to the state at this moment. And so I think this is something that we're going to need to, like, I've started talking about it when I do tick presentations, but it's hard because there's not a lot of data yet to really provide good risk communication about it. But I think it is something that we're going to start to hear more and more about, learn more and more about, and then we'll be able to say more useful things about it.
Yeah, we've had actually cases of that on the Cape, and ranging up with anaphylactic shock. We discovered established populations of Lone Star tick on the Cape about 3 or 4 years ago, and it has established a beachhead at a couple locations, and it is moving out quite well. So they're very happy on the Cape, but they're probably happy elsewhere too, and nobody's doing surveillance. Believe it or not, Barnstable County is the only county in the state that has a crazy person like me doing research like this.
Oh, okay. There are some pictures of Lone Star ticks in the back. You can learn a little more on the Tickies site. Thank you. Yeah. All right, for Larry, why not just spray a little bit of permethrin like you would DEET, maybe on the bottoms? Instead of soaking, I know generally what you do is you soak the clothes in permethrin, run them through the dryer.
Not anymore.
Yeah.
It used to be a shake and bake, put your stuff in a garbage bag and let it seep for a few days. Now you can buy aerosol products or water-based pump sprays, so it makes the application process a lot easier. So you just put your clothes over a porch rail and put your shoes on the deck. We don't know how long it lasts on footwear. The 6 washings applies to clothing only. I treat my footwear about every 3 or 4 weeks, and that seems to be satisfactory.
Okay. For any of you, how long can ticks survive off of a host, on a leaf, etc.? If they don't feed, what happens to them?
Okay, I get questions all the time from people. Larry, ticks are falling off my animal in my house. Should I be afraid that they're going to establish themselves like bed bugs or something else? What some really good research down in University of Rhode Island found is that when ticks come into a household which has much lower ambient humidity, they die very, very quickly. In fact, even out in the field, when you get drought-like conditions, ticks just move deeper into the leaf litter to preserve, maintain their hydration. Ticks are very susceptible to desiccation.
Where and how do ticks reproduce? We're talking about
The birds and the bees stuff. Adult stage ticks will attach to a host, both the males and the females, and while the males don't feed, when they're on a host like a deer or a raccoon, it's kind of like a singles bar. You just might find a friend. So they'll mate on the host, and then the female ticks will drop off, and then she'll lay her eggs in the spring, and it'll be a cluster of eggs. It might be 3,000 or 4,000 eggs, and they'll hatch out into these little teeny tiny larvae late in the summer, August into September, and that's their first opportunity for a meal. So yeah, the mating occurs on one of the hosts.
Thank you. How long is a tick testable for Lyme disease or other tick-borne diseases after it's dead? So they pull
We just
one
covered
off,
that.
stuck
You can
in-
just, Sam and I have talked about this. The Iceman, that was the mummified remains of a poor hiker in the Italian Alps. And with today's medical technology, they actually did an autopsy on the guy, so to speak. And one of the things they discovered in his body tissues, I think it was the bone tissue, right, Sam? They found the pathogen that causes Lyme disease. And that was 3,500 years old. The Lyme disease bacteria isn't something that started in Lyme, New York, and just radiated outward. It's been on this planet for millions of years, so it's a re-emergent disease.
All right. Would you talk, we thought this question might come up, would you talk a little bit about the danger of mosquito-borne disease? We've had some positive tests here for West Nile. Mosquitoes.
Larry, are you going to let me talk about mosquitoes? So,
Maybe.
In Massachusetts, we have two primary mosquito-borne diseases, West Nile virus and Eastern equine encephalitis. And the one that is more likely to occur up here is West Nile virus, although not exclusively. There are a couple advantages that mosquito-borne diseases have that we don't have with tick-borne diseases, and one is that surveillance for mosquitoes is easier than it is in ticks. And there is actually a mosquito season. They're not active all year round, and really the disease transmission is limited to really just a few months out of the year. And because we do surveillance, when I say we, I actually mean the mosquito control districts. They trap mosquitoes and send them to us for testing, and we can detect the viruses in them. That way we can send out alerts to people and let them know, okay, now we know that this is circulating in your area. It's time to really be serious about preventing mosquito-borne illness. We don't have the benefit of that with tick-borne diseases. We have hundreds of times the number of tick-borne disease cases in Massachusetts as we do mosquito-borne diseases, and I'm not trying to say that makes mosquito-borne disease not important, but we face different challenges with, I think, the tick-borne disease than we do with the mosquito-borne disease.
Thank you. For Dr. Dante, you talked some about testing and the unreliability of some of the testing. Is there a reliable test if you've been undiagnosed for a long time? And then finally, is there, in your opinion, a cure?
The laboratory tests, the existing ones, which are indirect, they ask the question, has your body responded to one of the components of the bacteria? And if you do have a response to it, that just tells you you've been exposed. But it doesn't tell you if you're sick or how sick are you. And it might actually be that some of the initial reports, studies that focused on patients who had a big swollen joint, had a rash, some signs of Lyme disease, who had strongly positive tests, were the people that actually did well. And that's why I think the field got a little confused, because some of those reports said these patients are treated easily. And it's the patients whose immune responses, if you will, are not as robust that might be the people who are sicker and go undetected for longer periods of time. That hasn't been resolved, but that's been my experience, and I think the experience of some other people as well. And it speaks to some of the variability of how ticks, how the bacteria are able to influence the immune system in a way that helps them survive. So we need a more reliable test. As I mentioned earlier.
So if we could summarize all of this, tick-borne illness seems to be very complex. Year on year, we're learning more, and we're uncovering other co-infections, other things besides Lyme that reside in the tick. Important, certainly, to rest on stronger, stable science at the same time that we're talking to people who are on the forefront of treating many, many patients for this. They have a lot of experience. So instead of asking someone you've never met on Facebook, maybe you want to speak to your physician and to trusted resources. But in all of this, the best medicine we can do is to prevent getting ill in the first place. So I hope you've come away today with some ideas that you can incorporate into your own lives to keep you tick-free. Thank you very much, and thank you to our speakers today. I know some of you had some personal questions. I hope our speakers can